Hello Internet, my name is Quinn and this is Blondihacks. I've done a couple of videos over the years on my favorite tools. Let's flip that upside down today and talk about my tool regrets. Now, that's not to say these are bad tools, to be clear, all tools are beautiful. These are just things that I bought that I thought I would get more use out of, or things that didn't work the way I thought they would, or didn't suit my workflow or the types of parts that I make, and so on. That might be a very different list for you, in fact I'm sure it is, but let's get into this topic. I think it'll be interesting, and it's definitely not schedule filler. First, let's talk about rotary tables. Very early on in my machining hobby career, I decided I needed a rotary table. I had a bunch of things that I thought I would make with it, and I decided, based on nothing, that a 4-inch rotary table was the size for me. I have a very small mill. I tend to make very small parts, models, that kind of thing. I figured 4 inches, that's kind of around the size of the part that I make, and I didn't want anything too big because I didn't want to have to store and manage a really large thing, and I figured 4 inches was probably about right. Well, this is a 4-inch rotary table, and it is very, very small. It is so small, in fact, that I think I may have used it once. Now, this is a very nice rotary table. It's a Phase 2, and it's extremely well made. There's absolutely nothing wrong with it. It's just so much more comically tiny than I expected it to be based on a 4-inch diameter. The rotary table that I ended up with is this Vertex 6-inch. Now this is actually a donation to the channel, and I'm very grateful for it because this is the size I wanted to buy anyway. What I learned from this to this is that the diameter of a rotary table is extremely deceptive for how large it actually is. You can see how much bigger you get just by going up 2 inches in diameter. And that's in all dimensions, in size and diameter, and especially in weight. The weight increase from rotary table size to rotary table size is immense. If only there was some sort of delicious sounding constant to characterize the relationship of diameter to other dimensions. Yeah. No, there isn't. But anyway, point being, when you're buying a rotary table, be very careful about what size you order, because the larger sizes are so much bigger than you think they are, and the smaller sizes are so much smaller than you think they are. To sell that point a little further, here's those two rotary tables on my mill. You can see that the 6-inch one basically covers the table on the y-axis, and the crank sits nicely outboard of the table, perfect size. The 4-inch one is comically tiny on here. The crank doesn't even stick out past the edge of the table, and I mean, you can see how small it is relative to the capacity of this milling machine. The hard lesson that I learned about rotary table size is that you need a bigger size than you think you do, because generally speaking, your part is using only half of it. So I figured, well, 4 inches, that's about the size of most of the parts that I make. So 4-inch table sounds about right. But no, you're typically centering the part at one end on the rotary table because rounded features are typically on the ends or the edges of parts. So you're mostly using the radius of the table, not the diameter. So this is really like a 2-inch rotary table. So even the small locomotive parts and other model parts that I make are sticking way out off of this thing. And then on top of that, you've got very little area to clamp here. Compare that to the 6-inch table. That extra inch of radius doesn't sound like it would make a big difference, but it makes a huge difference. It means I've got all this extra area down here for clamping and support, and my parts are only sticking off the table a little bit, all of which makes a huge difference. So it's really night and day between the 4 and the 6. But then you don't want to go too big. It would be tempting to try an 8-inch rotary table on this milling machine. Now, I don't have one to show you, but I have seen 8-inch rotary tables in person, and let me tell you, they are enormous and heavy. So this 6-inch table is just about what I can lift safely and comfortably without hurting myself with 2 hands. I could probably manage an 8-inch one. If you go to 10-inch, you better have a crane in your shop. That is a serious, serious piece of cast iron. These things have a lot of volume to them, and they are all solid cast iron pretty much inside. So again, that pi cube relationship with diameter means you're getting very, very heavy, very, very fast in an exponential relationship. So look up the weight of a rotary table before you buy one, and make sure you have the capacity to lift it and move it safely. Furthermore, you can see from here that an 8-inch one would absolutely not fit. Take that size difference from 4 to 6, and scale that up again by pi, give or take, and an 8-inch one is going to be enormous on here. Like it wouldn't even fit on the table and it would probably be too much weight, frankly, for my mill table, unless it was centered over the bed of the mill. What I learned is that the 6-inch size is a good model engineering size. The 4-inch is basically more like a watchmaker's rotary table. This might be good on a Sherline or a Proxon mill, one of those types. I'm not sure. I don't have one of those to try it on, but definitely something smaller than this. Maybe like the SC4 mills, the ones that are a little smaller than this guy. I'm not sure. But as I said, it is a beautiful rotary table. I absolutely love it, but I just really don't have any use for it. I keep it around in case someday I start making really small stuff, but I don't know. It might go on the for sale block soon. We'll see. Funny thing about unuseful tools, spending even more money on them does not tend to make them more useful. Realizing I wasn't getting a lot of use out of the 4-inch rotary table, I then went and bought the matching footstock for the mill, thinking, well, now I can do axial setups on the mill, so surely now I will get some use out of it. I have used this 0 times. You're going to notice a theme in all of these tools, and it's stuff that beginners think is useful that actually isn't. Enter the swivel base for a milling vise. I spent extra to get the milling vise with my mill that came with this swivel base. I had this swivel base on my mill for a year. Every single time I used my mill, I was frustrated by the loss of an inch of vertical height that this thing created. You know how many times I swiveled it? 0 times. 0 times. Rotating the part in the XY plane sounds to a beginner like it's going to be useful and something you're going to do occasionally. Turns out you basically never need to do that. I took this thing off of my milling vise, put it in a box 5 years ago, and have not regretted it for one day. Don't buy these. The other theme you might notice in this video is that it's mostly mill tooling, because mill tooling is a lot more complicated, and I think beginners fixate on the mill a lot more and imagine a lot of fixtures and such that they're going to want that they don't end up needing. The lathe, however, is a much simpler machine, much more powerful and flexible machine, but much simpler, so tool regrets are harder to find. I had to dig pretty hard to find something that I would call maybe a tooling regret on the lathe, but not really. So I bought this tiny little 3-jaw chuck. My reasoning for buying this was that I do occasionally need to hold parts that are too small for my 6-inch lathe chucks. Lathe chucks have a lower limit on the size of part they can hold because the jaws can only get so close together before they start to interfere with each other. So if you make a lot of really small parts, as I often do on the lathe, you do occasionally get into situations where the part is too small to be held in your larger chucks. So the idea behind this is that you can hold this chuck in a larger chuck. I put this guy in my 4-jaw chuck, put the part in here, and then dial in the part. And that does actually work quite well, and I have actually used this a few times. In fact, I probably would use it more, except that it's been in a box and I've kind of forgotten that I have it. But also, as I've gained more experience with working with small parts, I've learned other ways to hold things, especially the collet chuck. You know, once I got a collet chuck, this thing got a lot less useful. So not exactly a tool regret, but I haven't used it a whole lot. But now that I remember I have it, I probably will use it a little more again. You can see this guy in some of my older videos where I used it a lot more. Next up in my naivete sweepstakes are U-clamps for V-blocks. Before I got into machine shop work, my metalworking experience was mostly of the farmer variety. We did a lot of repairs on machinery and so on. You're doing a lot of welding, grinding, drilling holes in things, cobbling things together. And one of the challenges that you have in that environment is holding round things, and particularly cross-drilling round things. And for some reason, I thought U-clamps and V-blocks were just going to be this magic solution for that type of thing. Because I thought being able to clamp round things in a V-block and hold them perfectly was just such a cool thing, and I made sure to pay extra for V-blocks that included a set of these because they just seemed like the greatest idea ever. I have, I think, used these twice, and both times it was extremely awkward and I regretted it, and there were much easier ways to do it. I was falling into the very common machine shop beginner trap that a lot of tools are not as useful as they appear if you haven't actually done a lot of the operation in question. I could probably do a whole video on beginners' comments about boring heads and rotary tables and how people think they're way more useful than they actually are. And this is a tool like that I fell into that trap with. I thought I wanted this. Turns out what I actually wanted was this. This is a cross-drilling fixture, and once I made this, then I understood the problem I was actually trying to solve. This thing I use all the time. It's incredibly useful. This might seem silly, but it just never occurred to me that you can't use these for cross-drilling because you can't drill into the V-block. You can't hold the stock like this. So you end up trying to hold the stock out here and try to cross-drill out here, which doesn't really work very well. It's not a secure setup. It's not a rigid setup. You have to awkwardly try to clamp the V-block down in the drill press or go through other shenanigans. I even tried for a while using two of them to create a gap so I could cross-drill between them, and I went through a lot of effort to try and make these things useful. And at the end of the day, they just aren't. The cross-drilling fixture replaced all of those use cases that I imagined. The other use cases I imagined were fixturing round stock for doing other operations on it, and that turns out to be the collet block that I actually wanted. Because yes, you can fixture round things with a U-clamp, but when your part is sitting in this thing, you basically have zero access to it. You've got a little bit of access around the sides, but this tall clamp is in the way of the mill spindle or the drill press chuck or whatever you're trying to do, so you can't really get around access to your part when it's clamped in one of these things. So this is the classic beginner trap of, if you think about it for 5 seconds, it seems like a great idea. If you think about it for 8 seconds, you realize it's a terrible idea. So the cross-drilling fixture and the collet block are really the secret for all of the operations I imagined myself doing on round stock. These get used pretty much every day in my shop. These, as I said, I've used I think once or twice because I was trying to figure out how to make them useful and they just aren't. So then I put them in the drawer and got on with my life, and I've been much happier ever since. On the subject of collet blocks though, one other beginner lesson that I've learned the hard way in many situations is how much to spend on tools. I think when we first start out, a lot of us want to spend as little as possible, and I've talked a lot about that on my channel. There's a few areas where you really need to spend money. The one that I cite all the time is end mills. Do not buy cheap end mills. Buy high quality Kennametal or Sandvik or Niagara cutter. Buy high quality end mills. It will transform your machine shop life. Cheap end mills are absolutely terrible and they will frustrate you to no end, especially when you're learning. You won't figure out why you're not getting good finishes, why you can't take good cuts, and so on. It's the quality of your end mills. However, here on the collet block, cheap collet blocks are actually, frankly, great. Like, these are the cheapest collet blocks you can buy on Amazon, and they're surprisingly well made, shockingly well made, except for one thing, and that's the locking ring that comes with these things. I don't know why exactly, but this thing is beautifully made. It's nicely ground, it's very accurate, and for some reason, the locking rings they include with this thing are just terrible. They're made of some sort of butter steel. I think it might actually be plasticine, I'm not sure. But the clamping holes in it for the pin spanner that you're supposed to use to tighten it down wallowed themselves out in about 5 uses. And then I frustrated myself for, frankly, years with this thing, struggling to get the thing tight because the wrench wouldn't stay in these little holes. You can see how they're all chewed up. This thing is so soft, I don't know why they even bothered. Luckily, you can just go to an industrial tool supplier and buy a nice collet locking ring. So I did that, and well, now this thing is a good value. So there's little subtleties like that. You got to know where to spend money and where not to spend money on a hobby shop, and it can be tricky to know. That's my little speech on tool regrets. I hope something in here was useful to you. Maybe you learned a few tips about how to think about how you're going to be working, especially as a beginner when you're thinking about what kinds of tools you should buy. If you have similar tools that you regret, or maybe you just didn't use as much as you thought you would, or you paid too much for, or wasn't as good as you thought, leave a comment down below. I'm sure other people would benefit from that information also. Thank you so much for watching, and thanks to my patrons for making all of this content possible and keeping me and Swarfy and Sprocket in kibbles, as it were. And we'll see you next time.